Hey guys, so today I'm going to be going over test 5.3 review. It is quite a lengthy review. I wanted to make sure that you had enough opportunity to go through each topic that will be on the test and have enough review of each one. So I'm going to be doing 2 of each type in this video. There's a second video to watch that will go over 1 extra of each type, which my suggestion would be to work the orange ones and then watch that video just to make sure that you're doing them correctly, and then the yellow ones will be the ones that are taken as the grade. So there are 4 of each type on this review. That is why it is such a long review. I'll be doing 2 and then another, so in total I'll be doing 3 out of the 4 of each type, and you'll be doing 1 for the grade. And so again, my suggestion will be to go ahead and do the orange ones as well before you watch that video, so that way you are getting that practice in. So on the first section, we are adding and subtracting our radical expressions. So remember, whenever we're adding and subtracting, we have to make sure that what is inside is the same. So we are going to simplify first and then add and subtract. So we'll use our calculator and take the prime factors of each of those. So I'm going to do 135 first, and 3 to the third times 5. So we'll rewrite this. And then we'll do 162 as well. And it is 2 times 3 to the 4th. And then anything that matches the index in its power or higher is going to come up to the front. So now we've got 3 times 3, cube root of 5, plus 3 times 3, cube root of 5, plus 3 times 3, cube root of 2 times 3. So I'm going to rewrite this, multiplying out whatever I need to. And then remember, in order for us to be able to combine them, they have to match with the index and the radicand. So the cube roots of 5, they can combine, but the cube root of 6 cannot combine with those. So we have 18 cube root of 5 plus 9 cube root of 6. Then on number 3, the same thing here. We're going to find our prime factors of the numbers underneath to get negative 7th root of 2 to the 7th times 3 plus 3 7th root of 2 to the 7th times 3 plus 2 7th root of, and let's find the prime factors of 640, 2 to the 7th times 5. So in each of these, since our index is 5 and the power of 7, our index is 7 and our power of 7 matches, we're going to take out those numbers. So we've got negative 2 7th root of 3 plus 3 times 2 7th root of 3 plus 2 times 2 7th root of 5. Then again, I'm going to multiply out any numbers that I need to before I combine. And then we can only combine if they match exactly. So we have 2 of them that have a 7th root of 3, so negative 2 plus 6 gives me 4 of those. And then the other that we have is a 7th root of 5 which does not match, so it'll stay by itself. Then number 2 will be in the next video. On this next section, it's using the change of base formula to approximate our values of logs. We've got log base 4. Well, this would equal log base 10 of 16 over log base 10 of 4. And then we'll put that into our calculator and see what we get. And it gives me 2. I'll do the same thing with number 7. Log base 10 of 50 over log base 10 of 3. Put that in our calculator. And we get 3.561. Well, it says 10,000. So then that would be our approximation for log base 3 of 50. And then number 6 will be on video number 2. Now on the next section, we are condensing into a single logarithm. So we want just one log in there. And so first thing I want to do is change these to be powers. So we've got log base 4 of 3 cubed minus log base 4 of 11 to the 6. And that minus sign tells me that I can take them and divide. So log base 4 of 3 cubed over 11 to the 6, which I can simplify a little further. So I'm going to put that in my calculator. 3 cubed over 11 to the 6. So it doesn't really simplify. We have a really large number, so we'll just leave it that way because it's just going to give me 27 over, and then we've got like 1,771,561. So we'll just leave it with the 11 to the 6th power. But we do have a single logarithm, so we did condense it. And then on number 11, remember that when we have something over a number, it's the same thing as multiplying by that fraction. So we've got 2 log base 4 of z plus 1/2 log base 4 of x. So that's just a coefficient of 1/2, which will change into a exponent of 1/2. So we've got log base 4 z squared plus log base 4 x to the 1/2. And anything to the 1/2 power is the square root of it. So we're going to take those two and multiply z squared and square root x. We've got a single log, so we are done. Then number 10 will be on video 2. On the next section, we are expanding our logarithms. So this power first is going to come down. We've got 3 log base 8, 12 cubed plus 7. we'll expand further by separating with, oh sorry, it should be multiplied. Separating that multiplication. So we've got 3 log base 8, 12 cubed, plus 3 log base 8, 7. And I still have that power that can come down. So I get 9 log base 8, 12, plus 3 log base 8 of 7. And then nothing else can expand. And so we're done there. "14 will be on video number 2, and then I'll be doing 15. So on number 15, we've got log base 4 of the square root of 3 times 8 times 7. So remember that the square root is the power of 1/2. And our powers come down to be coefficients. So we've got 1/2 log base 4 of 3 times 8 times 7. So we'll expand further. Is 1/2 log base 4 of 3 plus 1/2 log base 4 of 8 plus 1/2 log base 4 of 7. And so we don't have any more coefficients, and we don't have any more multiplication or division, so we will stop there. In the next section, we are rewriting in exponential form from our log. So this is where we use first, last, middle. So the base is first, last, middle. So this would be 8 to the power of x is equal to y. First, last, and middle. U to the power of v is equal to 32 over 27. Then 18 will be on video 2. In the next section, we are rewriting in logarithmic form, which we still use first, last, and middle to convert back and forth. And so on number 21, our base is still first, last, and middle. So we would have a log of base u, v is equal to -3. And then number 23, first, last, middle. We have n. Oops, I was going to rewrite it as an exponential when it was already one. Log base n, there we go, of 85 would equal -3. So then on the next section, we're simplifying by dividing our radicals. So there's a number of different ways to do this. We could change it to the 1/3 power, or we could change it to what the cube root of 8 is, which is 2, and then the cube root of 64, which is 4, and then just simplify that fraction. So we've got 2 over 4, which is 1/2. So then on the next one, we've got the same type of problem. This time we have 1/2 on each of them. So the 1/2 is, of course, the square root of a number, and the square root of 6 is a decimal, so we can't just simplify them into their whole numbers and then simplify the fraction like we did on number 25. But we'll leave the square root of 6 alone for now, and then the square root of 25 is 5, so we can just write that as the whole number. And square root of 6 will not simplify any further, since 6 is just, 6 equals just 2 times 3. So we're not going to be able to simplify that any further, because it won't have any pairs to take out. Then on the next section, we're evaluating these expressions. So we've got log base 16 1/4. We want to know what that equals. And so we have first, last equals middle. So the way I like to do these is to convert them. Let's say 16 to the x power, or 1/2, not 1/2, or m, whatever you want to put there, equals 1/4, and see if I can play with this in order to make it 1/4. So if I make them the same base, let's see, that's 4 squared equals 4 to the negative 1, negative 1 power. So then I would say 2x equals negative 1, which means x equals negative 1/2. So I'm going to do that again. We've got log base 32 of 16. We want to know what it equals. So let's say it equals x. That's my first, my last, and my middle. 32 to some power equals 16. Now I want to make these the same base. So 32 is 2 to the 5th power, and 16 is 2 to the 4th. So then once I have the same base, the 2 and the 2, I can set their exponents equal to each other. So 5x equals 4, which means x equals 4/5. And x is what I was looking for, what the log equals, so 4/5 is my answer. Then on the next section, we are multiplying, but now we've got something that is distributing, and it has a radical on it. So we take outside numbers with outside numbers, and since we don't have one, it's just going to stay on the outside, and then inside numbers with inside numbers. And so we've got 3 times 3x, which is 9x. And then we'll simplify as much as we can. Square root of 9 is 3, so we can take out that 3. But 3 and x are not large enough to simplify. So we end up with 5x squared times the square root of 3x minus 3 times the square root of x. We'll do that again. So we've got inside 10 times 10, which is 100, and then x times x, which is x squared. Then we've got outside numbers, meaning it doesn't have a radical, and a radical. So 10x stays the same. Then 10 is the square root of 100, so 10 is on the outside now. Square root of x squared is x. And 10 is 2 times 5, so it is not large enough to simplify. And x doesn't have a power on it, so it will stay the same. Then on the next one, we are simplifying with multiplication and these exponentials. So we've got 2 to the 4th times 2 squared squared. So whenever we've got a power to a power, well, they multiply. So we've got 2 times 2, which gives me a power of 4. And then whenever we are multiplying, we add. So that's 2 to the power of 4 plus 4, which is 2 to the 8th. On the next one, again, we've got a power to a power, so this would be x to the power of 2 times 3. Let's write that in. Times x to the power of negative 3. So it's x to the 6 times x to the negative 3, which is x to the 6 minus, well, plus negative 3, which would be minus 3. So it's x to the power of 6 minus 3, which is x cubed. And I just went every single step there just so you could see it, but it would take less steps than that if you kind of condensed your steps into smaller ones, or larger ones, sorry. Next section, we're simplifying our radicals. So now we need our calculator to do our prime factors. So we're going to take the prime factors of 288. And we get 2 to the 5th power times 3 squared. Then we've got that x to the 4th and y. So now whenever we don't see the index, it is 2. So anything with a power of 2 or greater can come out. 5 divided by 2 is 2 with a remainder of 1. 2 divided by 2 is 1, no remainder. 4 divided by 2 is 2, no remainder. And then y doesn't have a power large enough. So we're taking out a 2, we're taking out a 3, we're taking out 2 x's, sorry, 2 2's. And then left inside are any remainders. We've got a remainder on that too. And then y. So rewriting that, we've got 2 squared times 3, which is 4 times 3. So 12x squared, square root of 2y. And the next one, now we've got a cube root of negative 48 which is 2 to the 4th times 3, and we've got u to the 7th times v. So anything with a power of 3 or greater, 4 divided by 3 is 1 with a remainder of 1. 3 isn't large enough. 7 divided by 3 is 2 with a remainder of 1. So we're taking out a 2 and 2 u's. Remaining inside is a 2, a 3, a u, and a v. So we've got 2u squared cube root of 6uv. Now next section we are solving equations. The first two we'll do are exponentials, and then the next two will be logs. So whenever we're solving exponentials, we're going to want to have the same base. Once we have the same base, then we can set their exponents equal to each other and solve. So we've got negative b equals b minus 1. We want both of our b's on the same side. So we get negative 2b equals negative 1. Divide by negative 2. And we get b equals positive 1/2. And then number 47, the same thing. We want to get them to the same base, which I know that 64 is 8 squared. So I can change this to 8 squared to the power of negative 2p. And 1 over 8 is 8 to the negative 1 power. 1 minus 3p. So this is 8 to the power of negative 4p equals 8 to the power of 3p minus 1. And then we have the same base, so we'll say negative 4p equals 3p minus 1. Subtract 3p. Negative 7p equals negative 1. Divide by negative 7. And p equals positive 1/7. And of course we would want to go back in and check that both of those work. And if they don't work, then they are extraneous. Now on our log equations, we have two different types. We have the type where there are a log on a single side with a number on the other side of the equal sign, and then we have log equals log. So the first one we're doing is with a number on the other side. So we want to condense our logs into a single log. So we've got log base 6. This is minus, so they're going to be dividing, of x over x plus 4 is equal to 1. So now we've got a single log equal to a number. We'll convert. And so we get 6 to the first power equals x over x plus 4. So 6 equals x over x plus 4. And we want to solve for x. So we'll multiply by x plus 4. Six x plus 24 equals x. And then subtract 6x. 24 equals negative 5x. And x equals negative 24 over 5. Now whenever we plug that back in, we do have to check, does it make my log negative, which it will. So this solution does not work, so there's no solution. Now number 51, we have a different type of log equation where we've got log equals log. We'll check that their bases are the same and that we don't have to condense anything. And then once we've got that, we'll just set them equal to each other. So v plus 3 equals 2v minus 2. 3 equals v minus 2. 5 equals v. Then we got to double check. Do any of them turn negative when I plug in a 5? We've got 5 plus 3, which is 8. So that's good. And then 5 times 2 is 10 minus 2, which is 8 again. They equal each other, and they're non-negative. On the next section here, we've got some word problems. So in 2006, there were 1,020,000,000 people worldwide using the internet. At that time, the number of users was growing by 19.5% annually. Write an equation representing the number of users from 2006 to 2016 if that rate continued. So we've got, in 2006, this large number of people using the internet, and it was growing by 19.5%. So the amount equals principal amount 1 plus the rate to the power of t. So the amount of people would equal that times 1 plus the rate as a decimal, to move that 2 places, the power of t. There's my equation. And then we want to know the number of users from 2006 to 2016. So 2016 is 10 years later. So A of 10 would equal And then you just plug that straight into the calculator. And we get a very large number, 6.0573 times 10 to the 9th. So I'm just going to keep that in scientific notation there. Number 54, a coin had a value of $1.17 in 1995. Its value has been increasing at a rate of 9% per year. I want to write the equation to represent this situation. So we don't have a value to find, we're just writing the equation. So my value in the end would be equal to 1.17, my principal amount, 1 plus the rate as a decimal, which would be 0.09, and we move that decimal twice to the power of t. And then that way we would be able to find the value of that coin at any time from since 1995. So that is half of the review completed, and then I highly encourage you to do the orange ones right before you check into video 2. Video 2 will be much shorter, obviously, because it's going over less problems, but that is all for this video. So make sure to check back with video 2, and then make sure that you're getting the yellow ones completed for your grade.